In this video, we will find several limits pertaining to this crazy piecewise function. For problem number 14, we are to find the limit as x approaches negative infinity of f of x. Well, if x is approaching negative infinity, we are definitely less than negative 3. So that tells us that this piece of the piecewise function will apply. In other words, we need to find the limit as x approaches negative infinity of 3x to the third power minus 27x over x to the third power plus 27. Because x is approaching negative infinity, we can talk about what matters most. So when you look at the terms in the numerator, the highest degree term is the 3x to the third power. This term is going to grow far faster than the negative 27x, so the negative 27x part is going to quickly become irrelevant. In the denominator, the x to the third power is going to grow the fastest. So these are the two terms that matter the most, which is why this limit will be the same as the limit as x approaches negative infinity of just 3x to the third power over x to the third power. So we got from the first step to the second step by thinking about what matters most. Clearly, looking at this next step, we have x to the third power in the numerator and we have x to the third power in the denominator. These are going to cancel each other out. So our limit will now equal the limit as x approaches negative infinity of 3. And the limit of a constant is just that constant. So the limit is 3. For number 15, x is approaching negative 3 from the left. That little negative sign on the top means we are approaching from the left. Because we are approaching negative 3 from the left, that means we are coming in less than negative 3, which is why this piece of the piecewise function will apply. I started to just copy this down over here, but I think I will begin to factor it as I go. So in the numerator, we have a common factor of 3x. So I'm going to go ahead and pull out the 3x, and that will leave behind x squared minus 9. The denominator will also actually factor, but I'm going to save that for the next step. So for now, I will just write x to the third power plus 27. So let's factor some more. So this limit will equal the limit as x approaches negative 3 from the left of so in the numerator we have 3x, and x squared minus 9 is the difference of two squares. So that will factor further as x plus 3 times x minus 3. The denominator is the sum of two cubes. So hopefully you have memorized that the sum of two cubes, or even the difference of two cubes for that matter, will always factor as a binomial times a trinomial, 2 terms and then 3 terms. The binomial is just the cube root of these 2 terms. So the binomial will just be x plus 3. For the trinomial, I'm going to look at the 2 terms I just put in the binomial, and I'm going to square both of them. So if I square the first term, that's x squared. Square the last term, that's 9. That gives me the first and last term of my trinomial. The middle term is going to be the product of these, so I'm going to put 3x, but the sign is always opposite, so I'm going to put a minus here. So that's how you factor the sum of two cubes. Now notice that we have a common factor in the numerator and the denominator. So we can cancel these out without affecting the limit. So this will equal the limit as x approaches -3 from the left of 3x times x minus 3 over x squared minus 3x plus 9. At this point, we can just do direct substitution. So x is approaching -3 from the left, but that means we can go ahead and substitute -3 for x. So in the numerator, we get 3 times -3 times -3 minus 3. In the denominator, we have -3 squared minus 3 times -3 plus 9. So let's see, this part right here, I'm talking about the 3 times -3, that is -9. And this part over here is -6. So we have -9 times -6. So the numerator is positive 54. Meanwhile, in the denominator, we've got, well, this is positive 9, and -3 times -3, so that's positive 9, and another 9, so that's 27. And 54 divided by 27 is 2. So the limit is 2. For number 16, we are being asked to find the limit as x approaches 0. So how do I know which piece of the piecewise function will apply? I see a 0 involved in the domain of this piece, but I also see 0 involved in the domain of this piece. So which piece applies? Trick question. We're going to have to evaluate and find the limit for both pieces, because for this limit to exist, the limit has to be the same as we approach 0 from the left and as we approach 0 from the right. So when we approach 0 from the left, we will deal with the 2x. When we approach 0 from the right, the other piece will apply. So we're going to have to look at both. So again, as x approaches 0 from the left, that means we're less than 0, which puts us in this interval between -3 and 0, which is why 2x will apply. So what is the limit of 2x as x approaches 0? Well, we can just do direct substitution on this, and that would just be 2 times 0, which is 0. Let's see if we can use direct substitution again to find the limit as x approaches 0 from the right. So as x approaches 0, let's replace x with 0. So that's just going to give me the square root of 6 minus 3 in the numerator. And in the denominator, that's going to give me -3. I don't need to simplify these to see that they are not the same. So because we got two different limits as we approach 0 from the left and from the right, the overall limit does not exist. So that is the answer to problem number 16. If this was part of a free response question on the AP exam, they will ask you to justify your answer. So then you would say the answer does not exist because f of x approaches two different values as x approaches 0 from the left and as x approaches 0 from the right. For number 17, we need to find the limit as x approaches 3. Let's look back and see which piece of the piecewise function applies. So as x approaches 3, where does that land? Well, as x approaches 3, we're going to be in this interval right here. Of course, x cannot equal 3, we can see that would cause a 0 denominator, which means that this piecewise function is undefined at 3. But that's okay, we can still find the limit as x approaches 3. The bottom line is this piece of the piecewise function will apply. So the original limit will equal the limit as x approaches 3 of the square root of x plus 6 minus 3 over x minus 3. We should always stop and think, will direct substitution work? Maybe we can just do direct substitution. But if we let x equal 3, in the denominator we're obviously going to get 0. In the numerator, if x is 3, then we've got the square root of 9, which is 3, minus 3, which is also 0. This is the indeterminate case, which really tells us nothing about the limit. So direct sub will not work. Instead, we're going to have to use some of our strategies. And usually when we see a square root, our number one strategy is to multiply by the conjugate. So remember, when I talk about the conjugate, if I have a plus b, the conjugate is a minus b. So I am going to multiply by the conjugate of the numerator. So because I have radical x plus 6 minus 3, I'm just going to write radical x plus 6 plus 3. And that's my conjugate. I will have to multiply by the same thing in the denominator so that I'm not really changing the value of the problem. I'm multiplying by 1. So the beauty of multiplying by the conjugate is that you always end up with a squared minus b squared. In this case, my a is this, and my b is this. If I take a square root and I square it, because I'm doing a squared, the radical goes away. So on my next step, okay, let me rewrite the limit part. So we still have the limit as x approaches 3 of. But right here, I'm going to put a squared minus b squared. A squared is just going to be x plus 6 because the radical goes away. Okay, now I'm going to do the minus b squared part. Well, b squared is just going to be 9. The denominator is unchanged, so I have x minus 3 times the square root of x plus 6 plus 3. What happens next? This will equal the limit as x approaches 3. Well, 6 minus 9, that's negative 3. So in the numerator, I have x minus 3. In the denominator, I also have x minus 3, along with some other stuff. X plus 6 plus 3. It is very useful that I have a common factor in the numerator and the denominator, because those are going to cancel each other out without changing the limit. So the limit will be the same as the limit as x approaches 3 of 1 over radical x plus 6 plus 3. Now it's time to do direct substitution. If we let x become 3, then we're going to get 3 plus 6 plus 3. And this is equal to 1 over the square root of 9, which of course is 1 over 3 plus 3, which is 1 over 6. By the way, if this was a free response question on the AP exam, you could stop right here, and that could be your answer. Or you could stop here, and that could be your answer. Or you could stop here, or you could go all the way to here. I'm showing you all the way to 1/6 because if this were a multiple choice question, probably 1/6 would be the answer that would be among the multiple choices. But just understand that you are allowed to stop at any numerical value along the way. For number 18, we need to find the limit as x approaches 14 from the left. So let's see which part of the piecewise function will apply. So regardless of whether we are approaching 14 from the left or the right, we are definitely going to be greater than 12. We're talking about values that are greater than 12, which means this piece of the piecewise function will apply. So the limit of the original function will equal the limit of this expression as x approaches 14 from the left. Let's go ahead and rewrite this in factored form so we can see what we are actually dealing with. So we will write the limit as x approaches 14 from the left of, well, x squared will only factor as x times x. 14 will factor as 2 times 7, but I'm looking at the middle term and I'm thinking we're probably going to do 14 times 1. To get a negative 15, we're going to need a negative 14 and a negative 1. So that's how this is going to factor down. I was also looking at the fact that the denominator has an x minus 14, and very often something is going to cancel out. So I was sort of waiting for that to happen. So since we have a common factor in the numerator and denominator, we can cancel these out without changing the limit. So this will equal the limit as x approaches 14 from the left of x minus 1. Well, that's it. Or are these canceled out? So there's no more denominator. So I will just say x minus 1. Guess what? Time for direct substitution. When we do our direct sub, we're going to get 14 minus 1, which is 13. So the limit is 13. For this last problem, we need to find a value of r, so the limit as x approaches 10 exists. Well, if the limit is going to exist as x approaches 10, it's going to have to approach the same value from the left and from the right of 10. So let's look back at the piecewise function and see which pieces apply. So I see the 10 here and here. So if x is approaching 10 from the left, we are looking at this piece of the piecewise function. All right, this is going to be from the left because that will make the x value less than 10, which puts it in this interval. If x is approaching 10 from the right, then we will be using this part of the piecewise function. Because from the right, x values are greater than 10, which puts it in this interval. So again, if the overall limit is going to exist, we have to get the same limit from the left and from the right. Let's start off by finding the limit as x approaches 10 from the left. So let's start off with this piece of the piecewise function. In order to find the limit as x approaches 10 from the left of this expression, we can just use direct substitution. We're not going to get 0 over 0. So let's go ahead and simply do direct substitution. So this is going to give us the square root of 10 plus 6 minus 3 over 10 minus 3. So this gives us, well, the square root of 16 minus 3 over 10 minus 3, which of course is 4 minus 3 over 10 minus 3, which is 1 over 7. So that is the limit as x approaches 10 from the left. Keep that in mind. So we need to find a value of r so that the limit as x approaches 10 from the right will be the same thing. So I now need to find the limit as x approaches 10 from the right, and the answer has to be 1 over 7. So let's set it up. So as I mentioned before, if we were finding the limit as x approaches 10 from the right, this piece of the piecewise function will apply. So r cosine pi x. Okay, so we need the limit of r cosine pi x. This is going to have to equal 1 over 7 somehow. Well, let's use direct substitution to find an expression for the limit as x approaches 10 from the right. So let's replace x with 10 in this expression. And so we should get r cosine of pi times 10, or I'm just going to go ahead and put 10 pi. Keep in mind that in the end, this is going to have to equal 1/7 to match the limit from the left. But for now, what we can do is evaluate the cosine of 10 pi. There's no reason why we can't just go ahead and find that. So mentally, remember that cosine is the x value on the unit circle. And right over here is pi. So as I rotate to this position, that's pi. If I go back to where I started from, that's 2 pi. If I went over another half turn, that would be 3 pi. If I went back to where I started from, that would be 4 pi. So the idea is all of the odd numbers of pi, 3 pi, 5 pi, 7 pi, they will all land you over here on the left-hand side. Meanwhile, all of the even multiples of pi, 4 pi, 6 pi, or the most relevant case is 10 pi, these will all land you on the right-hand side of the unit circle. So 10 pi is going to be right here, where the x value is 1 on the unit circle. So cosine is 1. So this is going to become simply r. Okay, and maybe I'll just put a little side note here that this is 1. Okay, now, like I said a moment ago, this limit is going to have to equal 1 over 7 so that the limit from the left and the limit from the right are the same. But since we're down to simply r, this is the final answer. R itself needs to equal 1 over 7.